As I will show you, we can't deny in certain cases a singular approach to each case, given the wide range of types of objects that have been addressed. But the most direct feedback of these guidelines is the ability to retrace the modeling process, and it's also given by the fast training of other operators in the future. So let's have a sense of what the chosen artifacts look like. There are various kinds of pottery, of ceramic pottery made on wheel by hand. Hand-modeled terracotta figurines, as you can see there. There are more tools, stone, carved in stone, and objects that are all dating from early to late Bronze Age, decorated with painted or engraved or stamped patterns, either naturalistic or geometric. They're all very interesting examples of domestic and ceremonial craft techniques and forms manufactured in the East Mediterranean or imported by Greece. As you can see, many digitized objects feature handles, necks, spouts, or multiple footings, like in the zoomorphic figurine, or rounded bodies that can hide parts during single acquisition positions. Other artifacts introduce different kinds of issues, as when decorative motifs are closely engraved or stamped, or if they have thin rims and sharp discontinuities on the surface profile. This is the scanning device we used, NextEngine's desktop scanner. Falls into the triangulation-based family of laser scanners. It integrates measurements derived by 4 laser strikes swept across the surface of the object, which turns on a rotating base on predefined steps. And NextEngine captures photographic information of the same fixed views. The instrument uses texture for a very precise geometric correlation. After tests, we decided that the quality of this photographic information, even if not very high, but could suit well the final targets of our project. And this, of course, is an advantage for the whole process because it means that no further texture mapping is required. Okay, as you can see in the technical specifications, the acquired area extent is quite limited, even at the wide distance, when the baseline between laser emitter and receiver is shorter, and so the acquisition goes deeper. But of course, it's always possible to combine and merge scans of several portions of bigger objects. According to our internal procedure policies, the biggest object to be scanned is about 30 centimeters tall, while larger pieces have been acquired with photogrammetric techniques by another project partner. The model reproduction process can be summarized in this basic pipeline. As well known, the acquisition phase is very short compared to the time occurring for elaboration of raw data. I'll just make a quick overview of the most recurrent problematic issues and time-costly issues throughout the pipeline stages and how we face them. The attainable results are based on this survey planning and setup. Decisions on the scanner software settings as range, distance, and resolution, and decisions on the placing positions and angles must be made minding these intents and in relation to these variables you see on the right. Plans have to consider always the reason why each artifact has been chosen for the project. So, for instance, if it's the shape features to interest more for scientific scholarly uses, accuracy and point density should be the main goals in order to have a true and reliable description of the morphology with a high level of detail. For example, I don't know if you remember one of the pictures we saw before, the so-called frying pan is an object whose function is still under discussion. It probably was a frame for a mirror. Well, archaeologists ask us to show exactly which probably has been drying on a mat or rack after modeling. So we acquired the bottom of this object in a macro, with a macro mode, so with a higher resolution, and while the rest was acquired in a wide mode. This is another case, but still it's an example of a vessel that has to maintain trace of the usage. You see a pot mark on the bottom of this flask. This flask was used to carry oils or ointments, and the pot mark was indicated the type of content or the quantity. In this case, we saw that even in wide mode, the detail was captured. It takes more time to study and prepare the placing of the artifact in the right perspective and to check for every position the scanner's field of view in relation to the rotation of the turntable. As I mentioned previously, during acquisition, we have to make sure that these objects that are fragile and often reassembled are properly handled and placed in the desired angle. And of course, the angle must be as close as possible to orthogonality in order to avoid noise in the resulting geometric data. This is another phase, the data acquisition phase. Regarding the third point of the list, on-site aligning is very useful. On-site aligning of the single scans of the sequence they belong to helps to orient the following acquisition sessions and suggests, of course, what parameters have to be modified. Regarding the fourth point, in the data archive where we store all files, we also keep a series of pictures taken of the scanning sets and a neat recording of the chosen parameters for each object and each sequence of scans. This information also will be useful during the modeling phase. Okay, here I show you how raw data appears in Scan Studio, the Next Engine software. For each position, we performed sequences of scans, they're called families, completing a 360 degrees rotation on the vertical axis to capture the body of the object, and triplets for the summit and the bottom of the object. Sometimes also single scans are needed for integrations. Here I wanted just to underline that we need coincidental visibility for both emitter and receiver sensors. So for undercuts views and hallowed regions, which shouldn't be arbitrarily reconstructed, wide mode is preferable because better results are obtained compared to macro mode. I won't be going in depth for this stage, leaving it to the proceedings paper. I just want to underline the importance of the trimming operations in order to filter data, reduce the overlapping of range maps, and keep the most valuable data, most precise, and with highest photographic quality. After eliminating useless data, so the different scan families are fused in a single triangle mesh. Here you see the trimmed sequences of scans registered together but not yet fused. Heritage objects like these can't be pre-treated to avoid reflections in the texture due to the shiny surface finishing, so trimming is needed also to edit the defects in the captured texture. Well, about this phase, I will just talk a little bit about hose filling. As you see here, the challenge is most of all to be able to regulate the available hole filling configurations and to adjust the new integrated mesh to achieve high fidelity to the real object. So here you see a complete reconstruction, mimetic integration in painting, we call it. About mesh simplification, all stages of the decimation have their own destination. Polygons decimation, as all other processing decisions, strictly follow the distinctive purposes of digitization. So we have these the three
Thank you very much for your nice presentation. There are any questions about the presentation? Okay, please.
Hello. When you're doing hole filling and decimation, are you recording the Faraday to the process of doing that? So, obviously you're going to be using London Charter, but we might...
Using what?
London Charter protocol.
Oh.
Or using Seville because
yeah.
It's more archaeological than buildings, architectural.
Yes, no, we do refer to the guidelines, and of course we do not want to fill holes for the copies that go to scholars and people in the field because they want the real thing, right? They want to measure the real thing. So, of course, the infilling part is only about, the models that will be processed to go on internet and on the touch screens for the virtual museums. And of course we try to be more faithful to reality as we can. We have pictures of the object, even if we have to paint the retrograded parts. We do try to keep high fidelity, and of course we don't see the difference in a way. So I come from restoration. I have a restoration background, so I know exactly the issues in here. But everything is balanced on the purpose, and the purpose is just to view the object in a 3D environment for education, but also enjoyment of the object.
So as a follow-on question, if I may,
yeah.
As coming from a conservation restoration background, would you say that treating digital objects in that manner is valid?
Well, it's valid only if I see the purpose of it. Yes. I would say that it's a good way for users, different kinds of users, to get to know the object if they can't really go and see it physically.
Okay. Great. Thank you.
These are objects that are not really seen.
Okay, thank you very much.